and so on, isn't it? Right. Now, what is the difference between a structure and an array? Anyone? Can you hear me, all of you?
Yes, sir.
Yes, sir.
What is the difference between structure and an array? Yes, good.
Stores same data type.
I can't hear your voice. Can you please speak aloud?
Array stores same data type.
Arrays can store similar data, whereas structures,
Different.
yes. So what is the name for structure? What is the other name? Arrays are also known as homogeneous data structures. And what we call structures are known as composite data structures, meaning what you can put inside structures different types of data as well. Like for example, here, let me give you a simple example. Now, see here, we have a, now if you want to define a structure, you should use a keyword struct, as we have struct here keyword. Okay. Now the name of the structure is student, and I am taking inside it two different type of data. Okay. One, I can include some more here. I can say double fees, right? I can say care, gender, right? And the list can go on and on, right? So this is a data type where you have more than one type of data inside it. Are you getting my point, all of you here? When we talk about an array, array can store similar type of data. If you say something like this, I'm just writing here. If you say like string name of 10, meaning what? You can store only strings inside this. You can't store integer or floating point here. Excuse me. Are you getting my point, all of you? So that is the limitation of your array. Now to address this, in C programming language, they have introduced this concept, which we call it as a structure. Now structures are implemented using the keyword struct. The syntax of structure is, this is the syntax of a structure. Okay, just put here in short, the syntax we have. Struct, keyword, name of the structure or identifier, followed by open, close, curly braces, and whatever you declare inside it, we call it as data. Okay, data of structure, right? Now by applying the same syntax here, we are writing the name of our structure is student, and we have name, we have ID, fees, and gender. Now, if you want to create an object for this structure, like for example, if I want to create integer variable, what I write first? First I write type, then I write variable name, isn't it? Or identifier, we call it as. Then if you want to assign some value, you can just assign value, which is optional. You can or you cannot, that's up to you, isn't it? Like integer a or age, you can just declare like this. You can initialize on the second line, isn't it? You can do this. Right? Now, similarly, if you want to initialize a structure, how you're going to initialize a structure? First, you need to write the structure name. Now, in our case, the structure name is student, isn't it? So student. Now, variable for this student is S. S, I'm taking S. You can take any S1, S2, S3, up to you. Now, if you want to initialize values, if you want to assign values to the members of this structure, like name, ID, fees, gender, isn't it? Now, how you're going to assign values to it? You're going to assign values to it by using, this is structure I take here inside it. So you have name, ID, fees, blah, blah, blah. So this is a structure we have here. First one, you're storing name. Second one, you're storing ID. Third one, you're storing fees. Fourth is you're storing what we call gender, okay, of type character. Now, how you can store values inside it? Now, this whole thing is actually a structure, right? Now, first you have name here, name, and a. Then next you have ID. Third one is fees. Fourth one is gender we have here. Okay, gender. Now, how you are going to initialize or how you are going to assign values to your structure? This is your student structure. The name we have given here as S. Okay, so I just write here student structure. Okay, now how you're going to put names? Like for example, I said here, okay, this, I said here S dot name. First, you need to create an object for that. That is, we are writing here student S. So an object will be created, right? Now S dot name. S dot name means you are storing James. So what happens here? The value James will be sent inside name. So here you have James. Now ID 1, 2, 3, 4, 5. Right. Okay. Now how you are going to assign? How you are going to access the members of a structure using this we call it as operator, using the operator dot. Dot is the operator. It's an operator. Full stop we call it in English language as full stop, but here we use the term, we don't use full stop here, we say it as dot operator, dot dot. Okay, S dot name. So dot is operator that is used to access the members of a structure. Dot operator. So S dot name is equal to James. S dot ID is equal to 1, 2, 3, 4, 5. Then you can access S dot fees, isn't it? Is equal to, let's say 5,000. Okay. Then S dot gender is equal to, suppose I'm saying here, since it is a character, so I just put here within single quotes, so N. So what happens here inside fees, you will be storing 5,000. So this is how in the memory the things will happen. Now next gender, you will have M. This is capital M we have here. Right? Is it clear? So now this is how you can store the values inside the structure. Now once you store, if you want to see the value, same again, you just need to use the dot operator and put it inside what we call C out. So S dot name, S dot gender, isn't it? S dot fees, S dot fees here, I'm saying fees, then S dot gender. If you want to write it in a neat format, you can just say name of student. Okay, right. Now next, let's copy it. Okay, just copy and paste here. Copy, paste, copy, paste. Name of, this is ID of student, ID, fees of student, gender of student. So this is how you can assign values, and you can, what we say, fetch the values from your given, what we call structure. Now compile it, run it. Compile it and run it. Okay, so can you see the output here, all of you?
Yes.
Yes. Now, as you can initialize variables directly, you can also initialize structures directly. Like for example, here you say S, comma, suppose I'm saying S1 is equal to, you can directly say, you need to follow the sequence here. Like for example, I'm saying here Williams, comma, then ID. So ID 4321, suppose, comma, fees. suppose 9,000, comma, gender. Gender is M again. Save it, compile it. Now, if you want to display the values from S1, so now you have two structures, two structure objects. Here we have only one, other one will also be created on the heap. Now, if you want to access, what you should do here, just copy paste, but in this case now you should call here S1. So S1, S1, S1. If you want to write some statement here like cout values from structure S, values from structure S. Okay. Now, similarly, this is the second one we have here. This is values from structure, S1. Okay. If you want to give some line here, you can give just for clarity. So compile it and run it. So you get values from structure S and values from structure S1. So this is how you can get the values from the structure. Yes. Yeah, the question is here, what's the difference between class and a structure? Now I'm coming to that point. Is this clear till here, all of you? So this is how we use structures. We can pass structures to functions as parameters. We can pass array of structures. You can create array of structures. As you can create array of data types, you can also create array of structures also. Structure basically is a user-defined data type. Unlike your primitive types, which are system-defined, by using system-defined primitive data types, you can come up with your own data type, right? So that we call it as user-defined data type. So when we work on real-world projects or real-time projects, there we need to design data types, isn't it, based on our requirements. So if you just take primitives, then that will not be sufficient. You need to come up with your own data types, and that flexibility is available in C programming language using structures. Now the question by one of our friends is, what's the difference between class and a structure? Okay, to put it short, classes actually contain both data and functions that operate on data. Here in structures, we only have data, but in classes, we have data as well as functions that operate on the data and in a single unit. That single unit, we call it as a class. Okay, is it clear, all of you, till here? Right. Now, extension to this concept of structures was given with classes. Okay, so that's the reason sometimes C++ is known as C with classes. Okay, C with concept of classes is actually C++. Okay, or you can also understand it as enhanced C. Excuse me. All right. Okay. So yeah, the question is, what's the difference line number 32 and line number 33 and 36? Yeah. Now the answer is, see, if you just write, okay, just let me write it something like this here. Then I write here. Okay. Now this line number 33. Now I'm putting it here. So this line, you are actually initializing on the same line, right? So, but whereas if you want to initialize, I mean, suppose now you have Williams as the initial value here. If you want to change it, isn't it? If you want to change the name to some other name, then you can just say S1 dot name is equal to, you can change it to, suppose Ravi. I'm saying Ravi here. Okay. Okay. So now with this like 36 until 39, you have an opportunity to give your own value, okay, line by line. Or if you want to initialize them on the same line, then this syntax is there to help you. Okay, I hope this clarifies your question. So this is if you want to initialize on the same line, you don't want to go one by one, you just want to initialize at one shot. Okay, so you can use this syntax. If you want to go one by one, then you can use this syntax. So you have flexibility here to initialize members of a class using this syntax. Okay, all right. Now coming to the point, what is the difference between a class and a structure? Okay, now I'm just informing you in brief. More we'll see when we try to write some programs. Okay, at this point, you just keep it in mind. What all the members, what all the data that you declare inside a structure is by default public. Okay, first thing. Second thing is, as you know, C++ is an object-oriented programming language. Now, when we say object-oriented programming language, now object-oriented programming language is based on object-oriented programming principles. Okay. Now, what are those object-oriented programming principles? Or we also call them as OOPS concepts. Okay. OOPS. Okay. OOPS stands for object-oriented programming system. Okay, right. And now, object-oriented programming system is based on object-oriented programming principles, and those principles we study under this category. We call it as abstraction. Then second one, we call it as encapsulation. Third one, we call it as inheritance. Right. Fourth one, we call it as polymorphism. Now, how we are going to apply this in C++? That's another course we have in your C programming, that is CSCI 221, where we talk in detail about these concepts, and we try to understand how you can develop object-oriented programming, what we call software using your C++ programming language. Okay. Anyway, I'm just trying to put it in short. Abstraction means, to put it in short, hiding the implementation. Okay. We call it as just exhibiting whatever is necessary and hiding what is not necessary for the user. Like, for example, to put it in short, you can use functions from your what we call math class, functions like exponent, isn't it? You can just say exp4, isn't it? But do you know how this function exp is implemented? Do you know? You may be using minimum maximum function from your what we call from your math library. You may be using sine function. Suppose I'm saying sine 40. You may be using cos, isn't it? Cos 90 or 30. Now there are many hundreds of functions are there inside your math library, but do you know what is the code, how it is implemented? We don't know, isn't it? Let me show you. Like for example here, hash include CMath. Okay. Now this is your CMath library. Now see here, just I will take, these are all prototypes. No definition. These are just prototypes. Like for example, here, just let me take the help of find now minimum function. Right. See here. Now fmin. This is fmin means finding the minimum of float, finding the minimum of double, isn't it? Finding the minimum. Finding the hypotenuse, finding ilib, isn't it? And so on. So these are all the functions that you have here. Right. Now, yeah, one more function I just would like to show you here. It's like exp. here, yes, let me go here. Hash include, if I say math.h, suppose math.h, minimum, yeah, minimum, yes. Minimum function. Let's show you minimum function here. Yes. See here, you have sine function, cos function, tan function, but do you have the code for it here? How it is implemented? Can you see the code here? Yes, can you answer my question, all of you? Can you hear me or not?
Yes.
So do you see the implementation for this? Implementation means the coding for this. Do you see the coding for it?
Yes.
No, this could. Neither you are interested to know it, isn't it? You just need to know what is the syntax, and you just need to know how you can work with that function, isn't it? Now, similarly here you have numerous functions. Just I am scrolling down to show you sine bit. Okay, yeah, exponent, exp, log functions. Right, hypotenuse, cubic root. See here, this is cubic root of double, cubic root of float, cubic root of long. So you just call CBRT and you can get your job done, isn't it? But how it is implemented internally, that is hidden from you. So this we call it as an abstraction, just exhibiting whatever is necessary and hiding what is unnecessary, isn't it? That we call it as abstraction. Abstraction we see in our daily life also. Like for example, you may be driving a car, but you need not know how the engine is working when you're driving a car, isn't it? Because if you focus on how engine works when you drive, you may hit someone on the road, isn't it? So abstraction actually helps you to get your job easier. So similarly in programming, in object-oriented programming, abstraction is used to hide the implementation, and it provides a facility wherein the programmer can just focus on what he should know and he can proceed with the development. That's it. Now coming to encapsulation, as you all know that data security is one of the concern, right? Now that data security or data hiding or information hiding is done with this mechanism, which we call it as encapsulation. Now this principle says that the encapsulation, it says that whenever you design a class, you should design a class with private data members, okay, and with public functions. Whatever data that you declare inside a class, you should declare it as private, and whatever functions that you have, you should declare them as public. Now, if you declare data with private, others can't access. Only the class functions can access it. Now, with these public functions, others, if they want to use your class, they can interact with your class with these public functions. Right, so encapsulation is actually one of the principle of object-oriented programming, which says that whenever you design a class, you should design the data with private modifier, and you should design the functions that operate on the data with public modifier. Right, now coming to inheritance. Inheritance actually is a mechanism where, like for example, like when we talk about C programming is based on functions, isn't it? But you may have one program, like a program that is implementing sorting functions, and you may have another program that may be implementing searching functions. You can't, how to say, if you want to develop a program wherein you want to reuse them, isn't it? Like best example, I can say that if you have a student class, now when we talk about students, there are many types of students. You may have graduate students, you may have high school students, you may have primary school students, you may have postgraduate students, isn't it? You may have students of different disciplines. So students actually, when you take any student, they share common properties, What are the common properties? They have name, they have ID, they have fees, they have gender, they have course, isn't it? Any student you take, whether high school, primary school, or undergraduate, or postgraduate, all the students, they share the same common properties. Now, in procedural programming, we don't have any facility to generalize a, a program wherein you can reuse them instead of recreating them, isn't it? So that reusable property is given with this inheritance mechanism. In inheritance mechanism, what we do is we derive child classes from parent classes. Now, how do we derive? How do we implement? That's the latter part. But at this point, you just keep it in mind that inheritance is a mechanism in object-oriented programming where a child class derives properties. When I say properties, it includes data. It also includes functions that are in the parent class. All right. Now, lastly, polymorphism. What is polymorphism? As you all know, poly means many. Morph means structure. Ism means system. A system which talks about multiple forms, isn't it? We call it as polymorphism. Now, just to give you a simple example. See, let me take your own example. When you are in my class, you are students, isn't it? When you go to home, you may be a son to a father. You may be a brother to a sister, isn't it? You may be a sister to a brother, isn't it? You may be a cousin, isn't it? You may be some other, isn't it? So you will be behaving differently based on the context that you are in, isn't it? So it means you are behaving polymorphically, isn't it? Now, when you develop your software, you can also change the behavior of the objects. Now, that aspect, we call it as object polymorphism. Object polymorphism. Now, one more interesting thing is we already implemented one form of polymorphism that was using function overloading, isn't it? Now, in function overloading, you have function with the same name, but based on its implementation, its behavior changes, isn't it? Some function is still some function. You can add 2 integers, you can add 2 floats, you can add 2 doubles, you can add 1 integer, 1 double, you can add 3 doubles, you can add 4 doubles, you can add, an array of double values or an array of integer values. So there the sum function is behaving differently based on the parameters that you pass to it. Are you getting my point? So that we call it as function polymorphism or method polymorphism. As you can have functions behaving differently, you can also have objects behaving differently. Okay, so that we call it as runtime polymorphism. That is beyond our discussion. But at this point, you just keep it in mind that these are the concepts that we apply when we develop object-oriented programming software, either using C++ or either using Java or C#, isn't it? Even Python for that case. So yeah, these are the concepts that we have in object-oriented programming principles. Okay. Now coming to the point, what are the concepts that we use when we write program using this object-oriented programming paradigm? Now, first and the foremost concept that we have when we talk about object-oriented programming, if you want to implement object-oriented programming principles in your program, the basic concept that you need to use is the concept of class. Okay, now what is a class? Class basically, I mean, to put it in short, I mean, if we talk from mathematical perspective, class is actually combination of data and functions that operate on that data. Okay. Now, there are many definitions for this. If you read over internet or if you go through the textbooks, there's some of them, they have called it as an entity. Some they call it as a description of an object. Some they call it as a blueprint, okay, blueprint for objects, and so on. Okay. So at this point, you just keep it in mind. What is a class from programming perspective? Class actually is an entity. Class is an entity that defines data of that entity and that defines functions that operate on the data of that entity. Like for example, I take entity. What is the meaning of entity? Any existing thing. It can be existing physically or it may be conceptual. Like for example, when I say like customer, isn't it? Customer is an entity. Now, what is the data of customer? Customer will have name. Customer will also have ID, right? Customer will have address. Customer will have, yes, customer will have what we call contact, right? Now the list goes on and on. Now this is the data. This is the data of customer, right? Now what could be the operations? Like you may want to, I mean, if you are developing a software, you may want to set the name, isn't it? So set name is a function. Get name is a function, right? Set address is a function. Set address is a function. Get address is a function. And the list can go on and on the functions list. So now when I say customer entity will contain data, and it also contains the functions that operate on that data. Now this data, if you declare it as private, right? And these functions, if you declare them as public, then your class becomes an encapsulated class. Getting my point, all of you? Now, in classes, we use these functions called setter functions and getter functions. Setter functions, we call them as mutator functions because set functions will help you to change the data of an object. Get functions will help you to get the data of an object. So that's the reason we call these functions as accessor functions and these functions as mutator functions. Mutate means what? Change. You can change the content of an object using this concept. Okay, is this clear till here? Any question, please? Okay, sorry. Anyway, now next. Cout name of, that is ID of a student colon, you can just say s dot get ID open close end line. All right, now save it. I am saving it as test class. Compile it. You're getting errors. What it's saying here, because we have not included any header file. So hash include iostream first thing using namespace std. That's it. Save it, compile it. Okay, compilation successful. Run it. You got the answer. Name of the student is Lee. ID of a student is 1, 2, 3, 4. So this is how you create an object, how you describe your class, isn't it? How you work with your classes. So this is the syntax of a class. As I said to you, it contains both data and functions as single unit. Data is declared as private. Functions are declared as public. If you want to access them, you need to create an object. This is a syntax to create an object. That is class name followed by object reference variable name. You are initializing the object with setter functions and you are getting the values of an object via getter functions. That's it. So this is a class. And this is how you implement a class. Is this clear? Any questions, please?